Hello everybody. Okay, in this video we're going to have a look at some different versions of sine functions and how we can draw them as graphs. So on your screen right now you can see that we have a sine function. This is the graph of y is equal to sine theta, and that is if this is our y-axis. So a good question would be, well, what would the graph of y is equal to 2 sine theta look like in comparison to this one? Well, if we think about this very logically, all we're going to have to do is get every value we have of sine theta and multiply it by 2, because that's what this graph is saying. We've got a 2 in front of it. So let's see how that affects the graph. So if I start with this particular point here at 0, if I multiply 0 by 2, I still get 0. So I'm going to keep that cross exactly where it is. At this point here, we have the graph of sine theta equaling to 1. So if I multiply that by 2, because I want 2 lots of sine theta, it's going to go up here. We better extend our axes on a little bit, and let's mark a point there too. So our graph is going to be right up there, and it'll look like this. And then at 180 degrees again, well, 0 times 2 is still 0. So at that point, we are back there. Now, if 270 degrees gave us an answer of 1, an outcome for y of 1, well, if we have 2 lots of sine theta, so 2 lots of that outcome, we're going to be at -2. So again, we better extend our graph on a little bit to have a -2 on it. So we're going to be right down here. And then again, you can see what's happening here. At 360 degrees, sine theta generated a 0 for us. So 2 lots of that sine theta is 2 lots of 0. Well, it's still 0. So this point is going to be back at 0. And there we go. There we are. And just like in all the other examples, well, this repeats itself 360 degrees. So at 450, we're going to be right up here at 2 again. Back down to 0 at 540, at 630. We're going to be back at -2 because of course, we did have -1. And -1 now multiplied by 2 is going to be down here at -2. And then at 720, of course, we're back again. So if I wanted to plot y equals 2 sine theta between 0 and 720, that will be the blue diagram there. So following on from this, I reckon you could probably see what y of 3 sine theta, because it's going to take all the original values that we had in this sine theta graph, and it's going to multiply them by 3. So this time we're going to need to extend our axes on even further, aren't we? Because that original 1 that we had there, well, is going to end up being at 3. And the zeros are going to stay the same, but the -1 will now generate a -3 like this. So if I wanted to graph y equals 3 sine theta, we have this situation happening. And we're stretching, if you like, the graph. We're stretching it parallel with the y-axis. And excuse my poor graph drawing skills, but it will look something like that. Now, this number in front of the sine theta is, of course, affecting the amplitude of the wave. So this number always stretches the original graph. So let's think now what that would look like on a cosine theta graph. So this graph in front of us now, this is y equals cosine theta. And I reckon we could do this very, very quickly. Let's think about this time, what will y is equal to 2.5 cosine theta look like? So, of course, every time we have a value, we need to multiply that value by 2.5 because it's the original function just multiplied by 2.5. So let's extend our axes. You will be using a ruler for this when you do this, of course. There's 2. There's 3. There's -2. There's -3. So if we were originally at 1 and we're timesing 1 by 2.5, well, clearly we're going to be at 2.5. If our original graph gave us 0, 2.5 times 0 is still 0. If we had -1, well, we'll now be at minus 2.5, and so on and so on and so on. So we can clearly see where to mark our points. And this is how we draw a cosine graph. And of course, exactly the same as the sine graph. If you want to draw a cosine graph, the same rules are going to apply. This blue line that I'm drawing now, very badly, that is 2.5 cosine theta. Okay, that's amplitude.